quartiles. So this is the last section. We're going to finish up, hopefully, quartiles, which is the next 2 pages. We already know the median is the middle of the data. And in statistics, they also have a first quartile. Quartile is a lot like the word quarter, and that's what it means. It's the first quarter. The third quartile is the third quarter. And so we have our definition. And a quartile, like a median, is the middle value of the bottom half. And then there's our median, or second quartile, it's sometimes called. And our third quartile is the middle value of our upper data. Okay, we've already talked about range in statistics just being the difference between the largest and smallest value. And we also will talk about the interquartile range. In other words, the difference between quartile 1 and quartile 3. Have you heard of outliers before in statistics? Okay? Right? If I gave you a quiz tomorrow about what we did today, and 15 of you got 100%, and 1 person got 0, the 0 would be considered an outlier because it doesn't fit with the rest of the data. Okay? Now, that's the situation of this class. Right? You could think about different sports. If you took horse riding, jockeys, and you weighed all the jockeys, they'd all be light. If there was one jockey that was 385 pounds, he would definitely be an outlier. It's not a good strategy to race horses with someone who's really heavy on the back of the horse. So if you're going to become a jockey, you're very small. And so the statistics of that has everybody really close to a certain weight. And having someone really heavy in that situation would be an outlier. In the same way, that person that was really heavy, if he was an offensive lineman in the NFL, and he brought one of the jockeys and say, we need someone to fill in today in the O-line, you'd be watching TV and you would recognize, right, what? That guy's tiny. Is that guy 5 years old? You would seriously probably think that guy was 5 years old compared to those athletes. Sometimes you don't realize how tall NBA players are because they're all tall. And you watch on TV and everybody's tall. But if they walked into this room, you'd be like, oh, wow. They're really tall. So that is an outlier. The way that we figure out what an outlier is we use our interquartile range. Because our interquartile range, which is the middle 50%, that's where most people are. And if someone is 1.5 times that number, past either quartile 3 or past quartile 1, then they're really far from the middle group of people. And we could say that that value is an outlier. So, again, we need to rearrange these values in order from smallest to biggest. So, median, you know, is the middle value. So I'm going to circle the median in red here. It happens to be 6. It's right in the middle. As soon as you have a middle value, then to find quartile 1 and quartile 3, you're now looking at just these values for quartile 1 and these values for quartile 3. What is the middle of these 4 values? Quartile 1 will be 4.5. What is the middle of these four values? Quartile 3 will be 7.5. The second one, we have an even number. So our median is right there at 12.5. And because the median is between 12 and 13, then to figure out our quartiles, we use all four of those values, because not one of them hasn't been used up by the median. In this case, quartile 1 will be 11 because it's between 11 and 11, and quartile 3 will be between 15 and 18. The average of 15 and 18 is 16.5. In part B, we would then say that our interquartile range, the difference between quartile 1 and quartile 3, is 5.5. And if we take quartile 3 and add 1.5 times our interquartile range, we will get 16.5 plus 1.5 multiplied by 5.5, and that adds up to 24.75. So this means that 25 is an outlier. Close. It's really close to on the edge. Right? So let's talk about a situation. You're talking to your friends. Everybody's got a job. How much do you make per hour? I make $10 an hour. I make $11 an hour. I make $11 an hour. 12, 13, 15, 18, 25. Some of those are below minimum wage, right? Okay, maybe you're babysitting. But the friend that's making $25 an hour, once they say that, everybody goes, what? Right? The 18 is good, but it's not like the 25 where you go, wow. So based on your friends in this friend group, that person that's making $25 an hour is outside what seems reasonable. Number of hours of sleep of 21 students. Did anyone get 12 hours of sleep last night? Yes. Wow. I'm jealous. I would love to have 12 hours of sleep. I usually aim for 12 hours of sleep every 2 nights. I'd fall into the 6 hours of sleep person. Total number of students, if we added them up, 21 students. How do we find the median? Which student would be in the middle? The 11th student. So if you organize them and wrote out 2 4s, then 5 5s, the 11th student matches up with person number 6. Just like we made a formula for median, where you can add 1, divide by 2, we can make a formula for quartiles as well. You can add 1 and divide by 4. Adding 1 and divide by 4 in this situation gives me 5.5. That tells me it's an average between the 5th person and the 6th person. quartile 3, you could just take this 5.5 and then multiply it by 3, which would give you 16.5. That would tell you quartile 3 was between the 16th and the 17th person. Yes? Well, because dividing by 4, because it's the first quarter, so then if we take the total amount and try to get where the 25th person is, we divide by 4. The reason we add 1 is probably easiest to see with an example where all your quartiles and medians work out to nice numbers. So if I, just off to the side here, go 5, 8, 9, 10, 10, 12, 15, 1, 2, 3, 4, 5, 6, 7 terms. If I add 1 and divide by 2, everybody's good with the 4th term being the middle. And then with the 3 that are left, this is easy to see that that's quartile 1, and this is easy to see that that's quartile 3. If I have 7 terms, good morning, and I add 1 and divide by 4, it works out perfectly to tell me quartile 1 should be in the 2nd position, which it is. The interquartile range, you'd have to find quartile 3, which we already talked about being between the 15th and the 16th person, which works out to be 8. And as a result, your interquartile range is 3. Perfect. So there's a little bit of corrections on there. And our last example, box contains 100 cards. Each card has a number between 1 and 6 written on it. And there are the frequencies of each number. How would you calculate the value of k? Add up all these values in which one? Like in the frequency? Add up all the frequency numbers. And what is it supposed to add up in total to? 100. Okay? Now again, what I want you to do in our notes, when we get to a question like this, I don't want you just writing things down. I want you to come up with, what's the idea that I need to figure this out? And then once we figure out the idea, I mean the math is really easy. It's the idea that's important. So this part, if you just write this down quickly, that makes sense. But as long as you're getting the idea, I know you could figure that out. It's hard to figure out questions when you have no idea. So if there's 100 terms, the median would be 3, quartile 1, 1, quartile 3, 5, interquartile range would be 4. How do you think I got all those numbers? I mean, again, you could figure them out, but you have to ask yourself, if I type this into list 1 and list 2, would it be quicker to get all these answers with my calculator? Or would it be quicker to get this by hand? Right? Depending how well you are with your calculator.